Okay, how we doing? Today we're going to talk about harmonics and the lab scope and timing. And we've got, if you look at your schematic, if you want to take a snapshot of that, we call this video, I don't know if you got a little sun there, noise diagnosis, noise diag. We're going to use 4 channels. We can only see 3, but I'll explain what we're doing. We have a Steelman chassis ear. That's that noise, the tool they use in the dealers to find rattles. We have hooked the Steelman chassis ear through an adapter, through a BNC to audio jack adapter to channel 3 of the scope, the C channel, the green channel. Within the Steelman chassis ear, we have three channels itself. So basically, we have 3 channels into 1 channel. I will move the dial to different microphones on the engine and tell you where those microphones are. Channel A, blue, is the ignition trigger for cylinder 1, so we can establish a firing cycle. That is every 720 degrees we'll see that trigger from the PCM to fire the ignition 1 coil. Channel B, red, I'm current ramping all the fuel injectors, and I'll explain that why. It'll make sense a little bit later into the video. I have channel D. You may not see that initially. I'll bring that down so we can kind of recognize a specific fuel injector. But nonetheless, we're talking about noise diagnosis, and we're talking about whether an engine has a noise in the bottom end, a connecting rod, a main bearing, a wrist pin, something along those lines, or something in the top end, something like a valve lifter or a broken valve spring, a rocker arm, a push rod, a cam load, a myriad of different things. We're going to try to sync our equipment here so we're able to disseminate where specifically the noise could be coming from. This engine does not have a abnormal noise. I will create some noises, I'll create some harmonics, and we're going to look at them on the scope and see where they are and where would we see noise on the scope, depending on where it's coming from, the lower end by the oil pan, as you can see, or the cylinder head, or the fuel injection rail. As far as the Steelman chassis ear, we got 3 leads coming out of that. Our first lead on the Steelman chassis ear is a microphone is clamped to the drain plug that we use to change the oil. That is the bottom end. The second latch on the Steelman chassis ear is going to the cylinder head central right there. See the microphone there. The third latch is actually the fuel rail, and I just want to see how everything relates to harmonics and timing, vibration, and sound. A little later into the video, I'm going to get into this guy here, if I could find it. If you can see that, let me get this so you can make better visibility of it. That is basically a microphone, and we're going to substitute this for the Steelman chassis ear as the same adaptation, just to see if we can locate specific noises. Now, this thing's mobile. We can move this around, and we're going to hook it to the 3rd channel, the green channel, and try to make a correlation between a certain sound and the timing of the engine, where it is in the fire cycle. Okay, I'm going to hook it to the scope. The scope is, I got to start the scope up. We're going to see 3 channels on the scope. We got green, we got red, we got blue. Blue is ignition trigger for 1. Red is a current ramp of the fuel injectors, and green is to the Steelman chassis ear. So we're going to get the engine running, and I'm going to create some situations that we could kind of make something of. If we were trying to diagnose an engine noise and we didn't know it was connecting rod, main bearing, upper end lifter, rocker, push rod, broken valve spring, VTEC pin. You know, there's so many ways an engine can make noise. But nonetheless, I will start the engine, and I'll try to shoot this video in 1 part. Should I feel need to do it in 2 parts, I will do so. We're live and running, and I want to get it going. Okay, we'll start the scope. The first notch on your Steelman chassis ear, as you see on your illustration, we're going to go to the drain plug, and we'll talk about that. Let's go to a different amplitude on that. And you can see we're running across the screen. That's our fuel injector. We'll talk about that later. Okay, I will go and I will, I'm just going to wing this and see what happens. I'm on the microphone hooked to the drain plug. I'm going to wrap the oil pan. I'm going to wrap the oil pan 7 times, and we'll just see what happens. scope. And what is okay, let's stop the car. Okay, we'll roll her back. Let's see what we got. All right. Okay. We can see something here. We got the 7 wraps. Let's kind of isolate them. We got 1, 2, 3, 4, 5, 6, 7, and then we kind of smooth out as the buffer goes down the line. This is all, I would call this the natural harmonics, other than me wrapping on the oil pan. But nonetheless, we can see our 7 contact spots on the oil pan right there. Okay, I'm going to do something now. I'm going to start the scope again. I'm going to do the same thing, but I'm going to turn the Steelman. I'm going to turn it to the cylinder head. That's the second notch on the Steelman chassis ear, and wrap the oil pan again. Okay, we're going along, and I will do the same thing to the oil pan 7 times. Stop the scope and analyze. I don't see anything abnormal. What's that tell us? That with the microphone now hooked to the cylinder head, we wouldn't pick up that wrap. It didn't pick up that wrap on the oil pan. So it's kind of the same situation as before, but this time I had the microphone switched to position 2. Now I will wrap on the cylinder head with the microphone on the cylinder head, and we'll just see what happens. 7 times. All right, stop the scope. Okay, let's see, filter it out. This is live. Okay, we should see some kind of anomaly with 7 wraps. Okay, maybe we see something there. Okay, didn't see that much. Let me try it again, and we'll see how valuable this could be as far as picking up a noise. I'm gonna do 7 times on the head. I am latched to the second microphone on the head. That was on the head. I did by the front of the head, by the timing chain. Let's stop it and go back. We got 3 here, and we got a couple here. Okay. Nothing really obvious, but maybe right here. Looks like I picked up 3 of them. Okay. Nonetheless, I will go and take the microphone, and I will put it back on the drain plug, and I will wrap on the cylinder head. I will alternate. I'm gonna do 5 on the head and 5 on the oil pan. And we'll see what we got. I'm going head first, not literally. hit 6 on the bottom one, so maybe we'll see that on the analysis. Anyway, I alternated 5. Our microphone in this situation is on the engine, the lower end, and we'll just see what we got. Okay, we got a couple little bit there. I think I'm sampled a little high. I'm killing my buffer. I'm eating my buffer. Let's try this again one more time. All right. Do it once more. Our microphone is on the lower end on the engine, on the oil pan. I'm going to the head 5 times. 5 on the head. 5 on the oil pan. All right, we're seeing something here. I can see 5 there. Okay, so the microphone picked up the engine block, but it didn't pick up the head. We can say that. I'm gonna do it once more like that, but I'm gonna switch the microphone to the cylinder head. We're on 2, and I'll do the same thing. I'll go from the oil pan with a rod to the cylinder head. I'm gonna start with the cylinder head. All right, we did 5 on the block on the oil pan and 5 on the head. We'll stop it. We should see just 5 high spikes, and that's it. Okay, there's our 5. Okay, that was, I would have to say, that had to be from the cylinder head. Let me roll it back and see what we got. Nothing. Okay, so it did not pick up the oil pan because our microphone wasn't onto the oil pan, but it was onto the cylinder head. So anyway, this is a good way. There are probably better ways. There's better transducers, but as far as figuring out the specifics of where the noise from, I would give this guy some try. It's the Steelman chassis ear, and you've got situations where you can hook it in multiple places, so we can see where it was sensitive to our specific noise. I want to talk about fuel. I'm going to switch the chassis ear to the 3rd latch, which is the fuel rail, and we'll talk about that. I'm going to get the scope running, and we'll talk about that. We can see something that makes some sense. Let me get about 5 volts so we're not greening the screen. Okay, you see, looks familiar what we're running across the scope now. Let's look at that, and I'll stop it and let's analyze. Looks like we have that again. Okay. Stop. Let me get the filter back. We've got too much filter. Let me take the filter off and I'll do this. Okay, I'm sorry. We're running now. Take a look. Okay, we'll stop and analyze. Look at a fire cycle. Remember, yellow is a fuel injector. Red is all the fuel injectors, and they're lining up really good. You see that? You see the correlation? The number one injector in yellow, the red ramp is for 1, and this is from the number 1 injector. We can see that. So think of the value in that as far as discerning some fuel flow issues, some specific noise. It's all about the timing of when the noise happened. When you use this kind of method, you know, it's one thing to pick up noise, but it's one thing to know when the noise is. So I just want to detour a second and go back to what I'll do here is I just want to talk about the blue guy, and I'm gonna shut the car off and talk about this situation here. That's a fire cycle. Okay. Okay, we can see the screen, and we can see injection. Now it's all making sense because the yellow and the green corroborate right there. That's our fuel injector, the harmonics of that injector. Okay, let me go back to talk about that in another way. I'll get real in on it. That's a fire cycle. That is the number 1 cylinder firing. I will set up some, let's set up, that is fairly close to top dead center for number 1. I don't know exactly how many degrees, but we're gonna, for intensive purposes, we're gonna call this a fire cycle. This is one at TDC coming down. This is one at BDC. Is one coming up on exhaust to TDC, down on intake, up on compression. What we know about this pattern is if we had noise on green, and we do have noise on green, we know that's fuel, those are fuel injectors. But if we weren't, if we were latched to the cylinder head or the engine block, like in the different situations with the Steelman, what can we say about the events here? What do we know happens about 40 degrees before bottom dead center? That's when the exhaust valve opens. So what does it take for an exhaust valve to open? A cam lobe's got to roll around. It's got to push on a lifter. It's got to push on a push rod, on a rocker arm. It's got to pivot. It's got to push down on a valve and a valve spring. And think of all the variables within there. I know that this does not have a cam and block, but nonetheless, a valve train. Think of all the components of a valve train and the action that takes place about 40 degrees before bottom dead center. That is when the exhaust valve opens. Right around here, this is our overlap period right here. Our intake valve opens, our exhaust valve closes. Think about those events. Intake valve opening, a cam lobe comes around, does the same thing. It's got to move that valve off a seat to get the air and fuel into the cylinder. A few degrees later, the exhaust valve closes. Think about what happens when an exhaust valve closes. A cam lobe rolls around to the flat spot. The valve spring pushes the valve closed. About 55 degrees on the average after bottom dead center. That's when the intake valve opens. The cam lobe comes around about right here and opens the intake valve. Again, there's contact with the lifter, push rod, rocker arm, things like that, down to the valve, and the intake valve would close here, right here, about 55 degrees after intake valve closes. That means the cam comes off the nose and it comes down, and the valve spring would close the intake, but still it's an action, and it's a dynamic action, so you have to think about that too. Think about what's happening in this fire cycle when we look at noise, how we'll be able to analyze noise, and it'll kind of narrow us in on where the specific noise can come from. So with the Steelman, we have options to use our microphones in different areas to narrow down the specifics of our noise. So, use triggers, use things like that to know where the engine is. And it doesn't just apply to cylinder 1. We could say, well, this is cylinder, if our firing is 1342. So if we triggered here, we say 180 degrees, that would be the next cylinder. Once if you know one cylinder and the firing order, you could deduce where that anomaly is on your microphone to see where your noise is coming from. I just want to start one more thing. I want to show, start the scope again and start the car, and we will okay. We're hooked to the fuel rail with our microphone, and let me just disconnect an injector for a second. So we had an injector disc. You might have heard the engine. We'll stop it and roll back and talk about it. Can we see that missing spot anywhere on the green? All right, it should show in the red. Let's get this guy out of here. We'll just keep rolling along, analyzing our channel, looking at red. Okay, we're missing right here. I seem to get it right in the gap, just my luck. Nonetheless, can you see? Okay, you can see that the harmonics went away, which is directly related to that fuel injector clicking away. You can see as clear as day. That's when I disconnected the injector. The green is missing. We know what cylinder, actually kind of figure out what cylinder it is. If yellow is 1, okay, we go to the left of 1, we go 1, 3, 4, 2. So what I did is disconnect injector number 2. So I just wanted to show you that. I'm going to make one more flip here. As I said, I'm going to get rid of the Steelman chassis ear, and I'm going to go directly to a microphone. And take a look at this guy here. I'm going to hook that to the adapter, turn it on, and I will go and I'm going to go to a fuel injector, and I'm going to see the relationship of everything. We're running across the screen now. We got our, okay, check. That's me. Okay. Now we're going to go to a fuel injector. I'm going to go to one fuel injector, and just think I won't tell you, and I want to put this next to the barrel of fuel injector. Okay, that's just normal noise. Okay, check, 1, 2, check. Okay, I was on that injector for about 8 seconds. We'll stop the scope. We'll see what we got. See if it comes to fruition that's an accurate method. Let me shut the car off. Okay. Okay, we can see some harmonics. And right there, I guess it's not super accurate. Maybe, okay. All righty. Okay. Okay. Well, I'm not really crazy about that. I don't want to give you any snuff jobs. Just take it for what it's at. It's a microphone, and it also works to your advantage in diagnosing noises. I just want to do one more thing, and that is to end this video. And I thank you very much. And hopefully there'll be a part 2.